All right, ladies and gentlemen, in this lesson we're going to take two things that you already know, and we're going to use them, kind of put them together to analyze a function like this. So notice maybe the new thing here is we have a 3x cubed as the upper limit of integration here. Other than that, it's kind of an accumulation function that is familiar to the types that we have been working with in this unit. And we're asked to find f prime of x, where this is f here. So we're going to review a couple things. The first thing is just a derivative of kind of a messy function here. And to start, I'm just going to rewrite it because that sign to the fourth means that, right? And that's easier for us to know what we're doing. And then I'm going to take my derivative. So f prime of x is going to be, well, the derivative of the outside function, which is 8 times blah, blah, blah to the third, and then times the inside of function, right, which is just sine of x cubed, times the derivative of the inside function, which would be cosine of x cubed, times again the derivative of that inside function, which would be then 3x squared. And then I could just simplify that just by multiplying my 8 times 3 to get 24x squared. Sine, I'm going to bring my exponent back in, and there would be my f prime of x. So the rule that we're using here, of course, is chain rule. And we used it twice, right? We used it here, and that's where I got my 3x squared, and we used it here, and that's where I got my cosine of x. So that's familiar to us, and when we're going to differentiate our accumulation function down here, we're also going to use chain rule. So it's a good time to review it a little bit and get a little bit more practice. The second thing we're going to review is just how to take the derivative of an accumulation function with just a plain old x, and that is very easy, right? Where like f prime of x just kind of cancels out. The integral is equal to 2x to the fourth plus 16x cubed plus 32x squared. So I really don't have to do anything with that other than drop the integration sign and rewrite it in terms of the variable x. So those two things we're kind of going to put together, right? So the thing to notice here this time is I'm plugging in that x everywhere, right? Everywhere I have a t, I'm plugging in that x. Okay? And the 0 doesn't matter because when I differentiate that, that's going to be a constant, right? So just the variable terms matter. Now, for our new accumulation function, it's going to be very similar, right? So f prime of x is going to be equal to sine of blah squared minus blah, right? But we are plugging now in 3x cubed, right? So that would be 3x cubed here minus 3x cubed. And then we need to do times the derivative of 3x cubed, which is 9x squared. Okay? So we just did chain rule here, right? And other than that, my derivative is the exact same as I did up here. And I, of course, can rewrite this a little bit more nicely. So I could say f prime of x is equal to sine of 9x to the 6th, so notice I'm kind of distributing my exponent there, minus 3x cubed times 9x squared. Okay, so differentiating these accumulation functions with that more complicated upper bound works exactly as we'd expect. We're plugging a function into a function, so we're going to use chain rule to simplify that. So overall, not a whole lot that is new here, right? Just being aware that this exists, but works how we would expect.